Everyone. We are currently scheduled for an on-time departure, so let's begin. Welcome to a crash course in writing your own PSScriptAnalyzer rules. My name is Thomas Rayner. I'm a Microsoft MVP for PowerShell, an honorary scripting guy. I've got some Pluralsight courses on Azure Automation that you can check out. You may find me on Twitter at Mr. Thomas Rayner, and I have a blog, workingsyssadmin.com. And what we're here talking about is making your own custom PSScriptAnalyzer rules. This is absolutely a crash course in doing so. It is a bit of a 45-minute sprint, so please hold questions to the end if there's time, and if there's not, Twitter's a good way to find me. Find me around here. I'm the guy who looks like me. And you can download the slides, demo scripts, any of that stuff for this and my other presentations on my GitHub page. So let's get at her. First, very quickly, just to do a little level setting, what is PSScriptAnalyzer for the uninitiated? Maybe you've used it before, but what it genuinely is can be found out by installing it and examining it. If you install it from the PowerShell gallery, you can check out the description on the module, make it a little easier to read. What it literally does is provide script analysis and checks for potential defects by applying groups of built-in or customized rules on the scripts being analyzed. So what's that actually mean? Well, there's a whole bunch of rules that come with PSScriptAnalyzer when you install it that will check your code for a whole wide variety of different best practices and style and standards applications. And you can extend this and customize PSScriptAnalyzer to check for things that you write. And that's what we're here today. We're not so worried about the built-in rules today. We are writing our own for our own purposes. Why would you want to use PSScriptAnalyzer in general? Well, the basic rules are, for the most part, pretty well reasoned. They're in there to help you. They're mostly based on things that the community and that the PowerShell team have decided are best practices and things that they want to see people do or see people avoid. They're not all perfect, as we'll discuss in a moment, but for the most part, they kind of make sense. PSScriptAnalyzer is a tool that will help you and your coworkers improve the readability of your script. So there's rules for things like not using aliases. If you use VS Code and you've seen the little green squiggles and stuff under aliases that you've put in, that's PSScriptAnalyzer analyzing your code on the go, saying, hey, you shouldn't use this alias. It would be more readable to use the full command name. There are a whole bunch of rules, and you can write your own to help make your scripts more secure and close vulnerabilities in them. There's default rules such as avoiding plain text passwords, although that rule is not perfect, and a variety of others. You can use PSScriptAnalyzer to enforce conformity across your code. So if you and I are working together on a project that's open source, or we're working on code together at our organization, my code should look like your code, should look like her code, should look like his code, so that when I have to go maintain your code while you're on leave or on vacation or change jobs, then it looks a lot like the code that I wrote. So regardless of what indentation schema you prefer, as long as we're all sticking to the same, we're pretty good. And you can enforce conformity rules and stuff like that. And then finally, the biggest one that we're here talking about today is flexibility. So with the custom rules, you can have this do just about anything you want. Being able to parse the abstract syntax tree will allow you to look through every single conceivable part of your script and determine whether or not it's playing by the rules that you want it to. There's all these default rules, but you can use PSScriptAnalyzer for any of the above purposes or ones that you make up on your own. Why would you not want to use PSScriptAnalyzer? Well, what drives people away are some of the default rules not so great. There's a bunch of them that are hotly contended among the community about, well, we should just take this one out, or this one's not perfect, or this one's really difficult to get your head around, or, oh, it's so many false positives. And they're kind of built for the 80% of use cases, and a lot of the people who are active in the community run into the 20% of use cases that are false positives or not applicable. The other thing that people end up criticizing PSScriptAnalyzer for, in my experience, are that not all of the default rules contain all of the use cases are not contained by the default rules. So there's lots of gaps. There's things that I wish ScriptAnalyzer acted this way. I wish that it would check for this. But there are ways of making it do that. We are concerned only with the second problem today. We're not really addressing the default rules, as I've mentioned. We are looking at building our own rules to try to fill some of the gaps that we perceive with PSScriptAnalyzer. There's a little prerequisite knowledge that we need before we can actually start making our own rules. Don't worry, we're almost out of the slides. The first is, what is AST? You guys were in Bruce's talk on Monday, but for the people at home, abstract syntax tree, it's a tree representation of the structure of code. Everybody with me, right? Everybody's got it locked down, perfect experts already. Come again. The abstract syntax tree allows us to break down PowerShell code into its structuring different components and parse the file into what's effectively an object that we can work with in PowerShell like we're used to. Still not with me? We'll show you. The biggest thing you need to know when we're making your own PSScriptAnalyzer rules is how to work with the AST, so it's going to be a large focus in what we're here doing today. Speaking of what we're doing today, it's demo time, and we are right on time. Here's our scenario. We have a feeling that having more than one parameter with value from pipeline set in the same parameter set is a bad thing. Regardless of how you feel about that, it's my presentation, so I'm saying it's bad, so it's bad. And the reasons for that genuinely aren't even important. We're not running any of the functions that we're actually testing today. We're literally just parsing them and looking at the abstract syntax tree. So we have two objectives in the demo that's going to make up the rest of our time together today. The first objective is to learn how to identify the violations. Before we can report on them and before we can actually make a script analyzer rule, we need to learn how to parse a script and look through it and identify, here is a condition where there are multiple parameters in the same parameter set with value from pipeline set. And we don't want to do that using regex because that sucks. The second thing we want to do is learn the actual syntax and how to build a custom PSScriptAnalyzer rule. Because it's great to be able to identify violations, but we don't want to have to reinvent the wheel and make our own rule running engine ourselves. That's what ScriptAnalyzer does. So we'll learn how to identify violations, and then we'll learn how to make PSScriptAnalyzer work with our code for identifying violations and get it all done. Be advised, this is far from a perfectly polished solution. You signed up for a crash course by sitting down in this room. So there is lots of room for improvement, but time constraints. This would take you more than 45 minutes to write in the wild, so bear with us. If you see stuff where like, oh, couldn't you have used that? Probably. But just to show you the basics and get you going and give you kind of the tools you need as a launch pad to get in and make the perfect rules you're after, this will get you there. Everybody clear? Good. So I have a few files open in my Visual Studio Code. I've imported a couple of modules already, and I'm going to clear this. So there we go. I imported the PSScriptAnalyzer module that you already saw we can get from the PowerShell gallery. And I've imported also this AST helper module, which is a module that I wrote that contains a couple of small functions and exists on the PowerShell gallery. You do not need this module to get started with script analyzer rules. There are lots of good alternatives out there as well. I just wrote this one, so I like it. And again, you're in my session, so you're going to see it. It comes with just a few commands. This invoke tokenize we're not even going to look at today. That was me goofing around. There are two functions in this module that I wrote that we're actually going to take a look at and use to dig into scripts with. The first is get AST type. And I'll show you what that does in more detail, but at face value, it's going to parse a file and tell you all the different types of AST objects that make up the abstract syntax tree for that file. The other one is get AST object, which will get you all of the AST objects of a specific type in a parsed file. It'll make sense as we go through it, I promise. So I've got this simple function that we can look at real quick first. And it literally just contains these 7 lines of code. It's got a test function. It takes one parameter, and this one's commented out. We'll be back later. And then it just writes output the value of that parameter. I'm not even going to run this code because it's not important here. And I'm going to store the path to that in the simple variable, just so we don't have to type that whole thing out. And if we look at the definition of what this get AST type actually does, let me make a little more room. This is just a comment-based help. I won't scroll up for that. Well, what it does is it takes one parameter, and it's the path to the script that we want to parse and get all the types of AST objects for. And then what it'll do is it's basically just doing some hand-holding for some of the AST methods here. The System Management Automation Language Parser class has a method called Parse File. And what that does is it's actually, like it sounds, going to parse the file that you give it and return the abstract syntax tree for that file. It takes the path to the file you want to parse and a couple of reference nulls. We don't worry about that, don't care. And I'm going to assign that output to the AST variable. Abstract syntax trees have a method called findAll that we're going to take advantage of in this thing. And what it'll do is it will search through the whole tree for things that match what's in this filter script that you provide it. In this case, arg0 not equals null. So I'm just looking for all of the different objects in the tree. And then it takes a Boolean. It's either true or false, like a Boolean. And what that does is tells it whether or not you want to recursively search through all the different script blocks that it finds in that file that you've parsed. And then what I'm doing with that is I'm just doing, for each object that's in the tree, I'm doing a get type because they're all different types of objects. And then I'm selecting the unique objects that I got. Then don't worry about the catch. I was a little lazy there. And so all I'm doing is parsing the file, getting all the different types of AST objects that exist there. So if I run that on that simple script that we saw already, you can see there's a whole schwack of different AST objects. There's a script block AST, parameter AST, pipeline AST, etc. There's all these different types of objects. And so the point that I'm highlighting here is the tree is not made up of uniform, concise, similar objects. The objects have a lot in common with each other, but they are all distinctly different, which means a lot of digging around on your part when you're writing a rule. So let's use the get AST object command that I wrote and just look at exactly what that does before we move on. Comment-based help above. So what it does is it takes two parameters. It takes the script path just like the last one does, and then it takes the type of the AST objects that you wanted to look at. So the first one is giving you all the different types of AST objects that are in that tree, and this one is giving you all the actual objects of the specific type out of that file. And what we're doing first is converting the type that you give it to the actual fully qualified type, so that when we do a comparison later, it'll actually work. And then this line right below it where we're parsing the file is exactly like it was in the line before. And then we're using the findAll method on that again. And this filter is a little bit different. Instead of just getting where they're all existing, we're getting where they are of the type that we're looking at. And that'll make sense in the next example. And then for each of them, I'm just writing them out. So if we do get AST object script path simple, type command AST, we're going to get all of the command AST objects in that simple script's abstract syntax tree. Turns out there's one. There's one command AST object in the tree that makes up that file. And you can see it's got command elements, invocation operator, defining, restrict, blah, blah, extent, and parent. The specifics of this are not hugely important quite yet. If we do the parameter AST objects, which are, you'll recall our demo that we're doing, our problem we're trying to solve are things that are applied to parameters, value from pipeline. We don't want that on every parameter in a parameter set. So it probably makes sense to look at the parameter AST and kind of see what's going on there. If we look at the parameter, it is slightly similar but distinctly different from the command AST. Parameter ASTs have attributes, they have a name, they have a default value, static type, whereas the command AST had a lot of different attributes to it. They also have an extent and a parent, just like the command AST did, but you can see they're different. They're different objects, even though they're in the same tree for the same file. So if I want to poke around with that some more, I'm just going to assign the value to a variable called param, and just like that, you can see that's what's in there. And so you might go, okay, so really easily, I should be able to, if I just want to retrieve the name of the parameter, maybe I'm writing a rule that makes sure that I capitalize the first letter of the parameter name, because that's my standard. So I should be able to isolate the name attribute of that parameter and check to see the first character is capitalized, right? Name presents itself as a string. Well, the next line's kind of giving it away. You'd be wrong if you thought that. And you'll find that with just about every attribute in an AST object is it may represent itself as a string when you write it out, but dig deeper because they're usually not. And so as we expand the name, it's a whole bunch of other stuff. It's got a variable path, whether or not the thing is splatted, the static type, and the extent and parent. Everything pretty much has an extent and a parent. So you go, okay, great. Well, all right, well, variable path, that's what I want. And you would be wrong again. There's user path. Is it global? Is it local? What scope is it in? Is it unqualified, etc.? Is it a variable at all? Is it drive qualified, etc.? What drive is it in? So you can see, and then finally, if we go and expand the user path, this is actually a string. We had to go that deep just to find the name of the parameter of this parameter AST object. So it can be a little deceiving, because if you just looked at it on the format list output of when we run this, oh, well, I can just isolate the name and work with it. No, dig deeper, because it's not always that easy. And so if we look at it again, what I want to explore quickly before we move on is this extent that's part of every AST object. And if we expand that, what this is it's a description of the code that makes up the AST object. So we have a parameter AST object. There's code in our file that makes up that object. So what file is it in? That's the first attribute. Where is it in the script? What column, row, line, where does it begin and end, etc. And it will tell you exactly where it is. And you'll notice this extent also has a text field and gives you the exact text that makes up that AST object. And that's going to be useful to us as we move on later into some of the other demo. So, and if I change this simple function, I'm just going to comment out this and make it so that I'm applying the string type and the making this parameter mandatory to this first parameter. That's all I'm doing there. And then we're going to take a look at how that changes the object really quickly. And so I'm going to have to refresh what's in that variable because it's stored in memory. And now if we look at it again, it looks very similar, but now these attributes are filled in. There's attributes in there. Do you think those are just an array of strings? You should know better by now. If we go in and we look, they're not. They're not even the same themselves. The attributes that are assigned to it, this string is here, type name string, and then type name parameter, and the argument that's passed is mandatory. And so we're slowly starting to dig in here. And keep in mind where value from pipeline is applied. It's applied inside of one of these parameter types. So if we isolate the named arguments from both of these attributes, well, the string doesn't have one. So if we do that, we just get the mandatory named argument out of the parameter attribute applied to our first parameter. It's getting a little deep and convoluted, but stay with me because this is how it works. And so if we switch to a more complicated file, this is one that we're actually going to see some violations to the rule we're building in. It's, again, a very arbitrary function. It doesn't do anything particularly useful, but it's going to highlight some of the use cases for the rule we're building pretty neatly. This is a function called getSomething, has Commandlet Binding Param Block, and it's got 6 parameters. The first parameter, mandatory, is set to false, and it's got value from pipeline. You don't have to specify equals true. Just specifying value from pipeline will make it true. Similarly, param2 also has value from pipeline, but it's explicitly equal to true here. So we have a violation. We have a problem. This script is going to violate the rule that we're going to build. And then we have param3. Oh, a different use case. It's present, but it's equal to false. So this particular parameter is not part of the problem because we're explicitly saying it's false, but it is present in this whole param block. Value param4, value from pipeline, is also false. Param5 has it as well, but it's in all lowercase. Maybe that'll be a monkey wrench later. And param6 doesn't have it at all. So this one, again, is also not part of the problem. It really does nothing of consequence. It writes the output in this one little write host here. And then inside of this, just to highlight another use case, we have a nested function called getSomethingElse. These two parameters, other param1 and other param2, are part of the same parameter set. Their parameter set name is equal to 1. And so this is a problem because you'll see value from pipeline is set here, and value from pipeline equals true is set here. So we have 2 parameters in the same parameter set that have value from pipeline set. These last 3, other param 3, 4, and 5, are all in parameter set 2, and only other param 5 has value from pipeline set. 4 and 3 both have it set explicitly to false, so they're not problems. So in this script, there should be 2 violations. This one where they're both in parameter set 1, and this one where they're both in the param block and there is no explicit parameter set labeled. Good? This is the script we're working with for most of the rest of this. So if we go back here, and I'm just going to set the path to that equal to a variable named complicated. And if I invoke ScriptAnalyzer on this file as it is right now, I get one warning. And it's the rule name, PS avoid using right host. It's a warning. In the script name, more complicated.ps1 in the line. And it tells me it's using right host. It shouldn't do that. You don't think it kills puppies, etc. And if we go and look at this again, line 26, in this file, right host, there it is. And so regardless of whether or not it actually belongs there, it is giving me a warning on that. So what it didn't do was anything related to the rule that I actually care about. Hello, we've identified a gap in the PSScriptAnalyzer rules, and we want to detect value from pipeline. So let us keep digging. How do we actually identify that error case in that situation where we have violations? It's great to scroll through it and point and go, that's broken. How do we actually do it in code? So we'll start like we started looking at the simple file by getting all the different types of AST objects that are in it. And there's a few more than there were, but there's a lot of familiar things in here already. Function definition AST, Param Block AST, parameter AST, etc. And we can take a quick look at like attribute AST, because the parameter attribute is applied to the parameter. So maybe we want to start looking at those types of objects. And we can look at just the first one of those. And well, the first attribute in this whole thing is actually Commandlet Binding. And it's applied to the Param Block. Well, and it's also applied to every single parameter that we have, but you know what? That might be a little too narrow for our focus, because we'd really like to loop through the parameters themselves so that we can report on which parameters are having problems. So we can look at the Param Block AST and just look at the entire block. And you'll notice as we scroll up here, it has that attribute, the Commandlet Binding attribute is applied to it. It's got parameters that are inside of it. These are probably parameter AST objects that are in here. It's got an extent, it's got a parent. That might be useful for us later, but a little too broad. Attribute AST was a little too narrow. This is a little too broad. We can look at the entire function definition AST to see what's in there and see that it's a completely different type of object than what we've already looked at. It's not a filter or a workflow. It's got a name that I bet is more complicated than it's being presented here. And again, too broad. But parameter AST, it's the Goldilocks rule. This one should be just right. So if we look at that, and we just look at the first one, we see it's param1, we see the attributes. We already looked at the simple scripts parameters, so this should be a little bit familiar here. And that's probably what we're going to continue digging around in and poking at to see what is going on. So I'll use the getASTObject command to get all of the parameter AST objects out of this file and store them in the variable params, because I'm creative. And if we just write out what's in this variable, scroll by really fast, you caught that all right. But you can tell by the last one, other param5 is the last parameter in the entire array of parameters in that file. So we got, if you don't believe me, we'll scroll up. There's all of the starts at param1, which was the first param in the first function, and it ends at other param5, which is the last parameter in the nested function. So that's what we got there. To make this a little easier, let's just look at the first parameter so we can work with that and just work on identifying whether or not it's a candidate for violating our rules. Does it have value from pipeline? What is it set to? So if we just look at that, again, boom, parameter AST object. We saw this before. We've isolated it here. And we already have a pretty good idea that we want to look at the attributes on that parameter, because we want to look at the parameter attribute to see if value from pipeline is an argument set there. And we can see it is indeed. It's got the string attribute and it's got the parameter attribute. And again, we're just going to isolate the named arguments on it here because we know that those are the in the parameter attribute. And we get the argument name mandatory, the argument is false, and the argument name value from pipeline, and the actual argument is value from pipeline. If we go back and look at our script here, let me just go down a couple lines. Here we are in param1. In the parameter attribute, we have mandatory attribute is equal to false, and then value from pipeline didn't get an explicit value, so it's just equal to value from pipeline. So maybe we can just trim out the argument names. So we see that it's got mandatory, it's got value from pipeline. Boom, there's an array. Does that array contain value from pipeline? Maybe this is a candidate for that. The problem with doing it this way is we're not quite off the hook yet. Mandatory is in this list, but it's set explicitly to false. So it's not enough just to see that they're in here. We have to see that they're in here and see what their value is set to. Specifically, we have to make sure that they're in there and the value isn't equal to false. So what we can do is value from pipeline even present? So we'll dig back into our parameter, and we're going to look at the attributes and the named arguments and the argument name, which was this little array here. And we're just going to convert them all to lowercase to take care of that weird one where the capitalization was weird. And we're just looking for the index of value from pipeline to see if it's present. And its index is 1 because array start at 0 and mandatory is 0 and value from pipeline is 1. So it's in there. If we look at the one in the 5 slot, that's param 6. And you'll recall that one didn't have value from pipeline in it at all. So if we run the same code on this other parameter, we'll see that it returns -1. So knowing how this index of method works, we can reason that if value from pipeline is in any way associated with this parameter, this command will return an integer greater or equal to 0. And if it's not, it'll return -1 or less than 0. And so that will isolate the we need to look at it closers to we don't need to look at this ones anymore, just to see if they're there or not. If we look at the param in the 6th slot, that's other param 1. We can do the same thing with parameter set name. Because remember, if they're in different parameter sets, they're not going to be called at the same time. So we don't worry about that so much for this. And we can see that the parameter set name is in the 2 slot of this attribute. Mandatory is in the 0, value from pipelines in 1, other parameter set name is in 2. Good? So we're left with 3 scenarios here. If we look at this complicated script, and they're captured in the first 3 of these. We're not worried about param 6 because we've already figured out how to ignore those ones. But we're worried about param 1 where it's there but not explicitly set to anything, but it's there, which means it is true. We're worried about these ones where they're there and they're equal to true. And we need to remove what could be a false positive of these value from pipelines that are present but equal to false. So that's what we have to actually identify and look at. So if we look at our first param and we look at the named arguments, we see that it's got mandatory equals false and value from pipeline is value from pipeline. That's our first use case. And if I get the index for that one and I just store it in the value from pipeline index variable, I can go back and get the named argument that's at this spot in the array. And I can see that I've isolated the value from pipeline argument in that attribute. And I can look at it and see what its actual argument is to see if it's false or true or whatever. Yeah, I could do this with some where object stuff. I could do this a whole bunch of different ways, but you'll see why I'm doing it this way as we kind of carry on. And if we look at the argument that's actually passed, this is the argument here. The argument is value from pipeline, but of course it's more complicated than that. The value is actually true. It's a Boolean, but if we look at the extent, we can see that. And if we look at the text that makes up the extent, we can see that the actual argument being passed is value from pipeline. As we look at the next parameter and just do the exact same thing, see where in the array of attributes the value from pipeline is, make sure we isolated that one specifically on its own, and look at the argument that it's passed. We can just skip a step here and see what the actual text is. It's equal to true. So we found a parameter, we found that it has value from pipeline, and we've identified both of our true cases, where the value is just value from pipeline and where the value is true, because that means that we've actually got this thing applied in both cases. Here's one where it's present, but it's equal to false. This is the third example here, and we'll isolate where it is by getting the index of it, and we can see the argument name, value from pipeline, the argument itself is false, so it's not present, it's not a problem. And if we just look at the text that makes that up, it's false. So we know that the first parameter we looked at is a problem because it's there. We know that the second parameter we looked at is a problem because it's there and it's equal to true. And we know that the third one is not a problem because it's there, but it's equal to false. And using this value from pipeline index type of variable, if it's -1, it means it's not present. We don't have to worry about that. And so if we do the same thing for parameter set name, I'll just do this real quickly and show you that we successfully isolated that parameter set name in the other param 1, the next one in the list. And if we look at that argument itself, this is a completely different type of attribute, and it's single quoted, values 1, etc. We could probably use this value, but we can also just use the text that makes up that actual piece of code and isolate it as 1. what this means, I'm just going to get the same for the value from pipeline there, is we can build ourselves a little custom object. And what it does, I'll just run this line and show you. We can go through all of the parameters that are in the file and strip out and make ourselves very easily comparable objects that contain the parameter name, the value from pipeline, whether it's true or false, or value from pipeline, or whatever it might be, and the name of the parameter set that it's in. And then what we can do is take these, if we go through all of the parameters and make a little object like this that's really easy to work with, we don't have to do as much messing around with the really complicated AST objects. And so we can go through and say all of the parameter, so everything in this little array that is in parameter set 1, is there more than one that has value from pipeline in a true state, then we can report what those ones are. And so what I did here was I just made a custom object based off of the name of the parameter using our big, easy to remember path to that attribute. And then the exact same thing that we did above. We got the value from pipeline and the value for the parameter set name. How are we doing here? We're doing okay. Maybe now we can make this into a PSScriptAnalyzer rule. We've done a pretty okay job of analyzing the problem. So every PSScriptAnalyzer rule that's written in PowerShell and not C# is in a PSM1 file. And within there, they're in a function. You can name the function whatever you'd like. I've named this one. This is just the skeleton of what most of them all look like. Is deny value from pipeline, have Commandlet Binding, have an output type. These actually output diagnostic record objects, but I'm lazy, so it puts out an array of PS custom objects, and PSScriptAnalyzer can figure out if they're valid or not. And then it takes one parameter. It is a mandatory parameter that I am validating not null or empty, because why just wear your belt when you can wear your belt and your suspenders? And it takes, that parameter is a script block AST, because that's what PSScriptAnalyzer is going to give our rule. It's going to give it a script block AST object into a script block AST parameter. That's the name of the parameter for the very intuitively named script block AST for a script block AST object. Then inside of a process block, because we're taking these things in from the pipe maybe, I like to put it inside of a try just because, well, I'm troubleshooting these things, it's easier, and the PSScriptAnalyzer will suppress a lot of your errors. You got to first identify all the violations. So you need to compile the code and write it and put it in there to actually find where your violations are. And we'll come back to that in a second because we sort of covered that. We just haven't put it all together yet. And then what it'll do is write out one of these diagnostic records, or as I've lazily labeled it, a PS custom object. Excuse me. Which contains at least these 4 attributes. The first is a message. This is a very valuable message just in my skeleton, so I'll go back and replace that with something a little better. The extent, remember those extents? It tells you exactly where in the code the piece of, or where exactly in the file the piece of code we're looking at is. The name of the rule that gave us our violation, and the severity level, whether it's informational, warning, or error. And then, just as I have it here, this will get written out into the pipeline and displayed and formatted in PSScriptAnalyzer. So if we take the path to that custom rule, this is a valid rule, and go invoke script, I type so good in public. We're going to do it on the complicated script that we've been looking at. And how do I use my custom rule? Well, luckily for us, there's a custom rule path parameter, and I just put it in there in quotes because it got spaces and stuff in the name. This will only run the custom rules that I give it. And I can give it a folder, and I can give it a wildcard, and I can run a whole bunch of different rules, but this will only run the rule that I give it. If I want it to run all of the default rules or a specific subset of the default rules and my custom one, I need to do something like include default rules, because otherwise it'll go, you clearly just care about your custom rule because you didn't explicitly put in all the default ones. But because we're here to learn about custom rules, I'll just run that. And I can see that I got 3 errors. And they're all very valuable messages. But you can look at the object that we wrote out, and you can see how it forms what PSScriptAnalyzer actually gives you. It gives you the rule name, which was my invocation, which was the name of the file and the name of the function inside of it. So I like it in this format for my custom rules because maybe I have more than one in the PSM1 or whatever. The severity was a warning, and then it's got a script name and a line number. Well, I didn't give it that. I gave it an extent instead, and that extent was used to format this output and tell you what file it's in and what line number it's on, and then our message. If we look at one of these things, if we look at one of those, we can see they're more complicated than the format table output lets on. Here's line 1, column 1, message, very valuable message. This is all information. The extent object is in there as well as the rule name, the severity. If I had a rule suppression ID, I could have seen that in there as well. And suggested corrections are something that are awesome to put in there. When you're using VS Code and the little light bulb pops up and says, you should change select to select-object. And you go, no, I like it the way it is. No, when you go, yeah, okay, I'll do that, and you click the light bulb and it expands it, it's because it's using that suggested correction. We don't have time today to talk about suggested corrections, but I highly recommend looking into them because they're neat. So that is the skeleton. That's the framework that we're building around. We are receiving this script block AST, and then we are doing our voodoo to identify our violations, and we are going to write out diagnostic records, errors, instances of the violation, so that PSScriptAnalyzer can do its little magic at the end and format them nicely. So, just like a cooking show, I've got something I prepared earlier. And deny value from pipeline.psm1 is a PSM1, just like the skeleton we looked at. And you're going to start seeing the stuff that we were doing in the line-by-line execution and the stuff we were doing in the skeleton start to kind of merge together. We've identified the violations, we've looked at the formats, and now let's marry the two together and get this thing done. So the function deny value from pipeline has Commandlet Binding. It has an output type of PS custom object because I'm lazy. It's diagnostic record, we all know that. It takes one parameter that's mandatory, and it is script block AST, which is a script block AST object, just like the skeleton. We just saw all this. It has a process block, and now we get into identifying the violation. We kind of already did that, but let's put a nice bow on it. These two lines are doing what getASTObject does. That one little wrapper function that we saw kind of near the beginning of the demo, it's going through the AST that it's been passed. So we don't need to parse the script because PSScriptAnalyzer already did that. But so we received the abstract syntax tree, and we're going to find all of the, first I'm getting all of the param blocks that are in there. And you'll see why I'm doing that as we write out the errors. And I do not want to go recursively through all of the different script blocks that I'm being passed. I just want to look at the one that PSScriptAnalyzer gave me. Because PSScriptAnalyzer will give me all of the individual script blocks, so I don't need to go and dig deeper. Then, on line 13, I'm doing the exact same thing, except instead of param blocks, I'm getting the parameters themselves. And that makes more sense, because that's what we're going to loop through here. So I'm going to make an array list because I attended the performance-related session yesterday, and I know that that's better than doing plus equals all the time. And I'm just naming it param eval, and that is going to hold all of those little custom objects that I kind of created for the sake of going through them, all in a neat little bow, and allow me to kind of do my evaluation that way. So for each of the parameters that we got out of the script block that we're looking at, this looks familiar, right? I'm getting the index of value from pipeline, and if it's in there, if it's greater or equal to 0, I'm storing the actual argument that it is. So it's either going to be value from pipeline true or false. If value from pipeline index is less than 0, then I'm cheating and I'm just saying it's $false because it's implicitly false by not being included. I'm going to do the exact same thing for the parameter set name, which is doing the get index there. And if it's greater or equal to 0, I know that there's an actual parameter set name applied there. So I'm going to store the text of it. And if it's not there, I'm just going to use no param set name to denote that it does not have a parameter set name attached to it. And then I'm adding myself a little object. This looks familiar. I'm adding the name of the parameter, the value from pipeline if it's present, and if it's not present, it's just false. And I'm adding the parameter set name value, which is either the name of the parameter set or no param set. And then, almost done here, I'm going to go get all the unique parameter sets because I've gone through all of the parameters. I've made my nice little easy to look at objects, and all of the parameter sets are going to be listed individually there for each of the individual parameters. So get all the unique parameter sets so that I can go through each parameter set in this script block. Because what I want to look at is to make sure that no two parameters in a parameter set have value from pipeline set. Staying with me here? So all of the parameters in this parameter set can be found by going all of the little custom objects that we made where the parameter set name is equal to the parameter set that we're looking at. And then we're going to get, for all of the parameters that are in that parameter set, all of the ones where the value from pipeline value is not equal to false. So ideally, there should be 0 or 1 equal to false there, or not equal to false. So if it's greater than 1, that means that I have more than one parameter that has value from pipeline in the same parameter set that is not equal to false. And so I'll write my object out. I'll write my message. There were however many parameters in the same parameter set, name of the parameter set, with value from pipeline specified as true. Shouldn't have more than one, because I said so. The offending parameters are these parameters that we're actually looking at. Here's the extent, and I'm using the extent of the Param block. That's why I retrieved it earlier, because this is a scenario where I'm making a design call. There, in the first param block, I had parameters 1, 2, and 5 that all had this thing set. So do I use the extent for the first one or the extent for the second one? I can't use the extent for the second and third one. So I'm just going to use the extent for the param block and say, go look at the param block. You've got messed up parameters in here. The name of the rule and the severity I've decided is a warning, and that is our rule. Whoop, let's not give it away there. You want to see if it works? I do. So we'll just run, it's in the same directory because I'm so forward thinking. Deny value from pipeline. Okay. So we've identified violations. We've identified 2 violations because we have 2 instances where this thing's broken. Let's look at them very quickly because we're running low on time. So the rule name deny value from pipeline, that's the file. Deny value from pipeline, that's also the name of the function. It's a warning. Here is where it is in the extent. We'll look at that if we can. And then the message. There were 3 parameters in the same parameter set, no param set name because it didn't have a name, where value from pipeline was specified as true. You shouldn't have more than 1. The offending ones are param 1, 2, and 5. So if we look at more complicated here, we can see param 1, 2, and 5 had value from pipeline set. And if we just scroll up to make that easier to look at, on line 3, this is where the param block begins. So I'm just telling you, hey, go look at this param block because things are jacked up. This one is true, this one is explicitly true, and these ones are false, so we don't worry about them. You did fine there. And this one's also true. And this one, you didn't mention it, so that's fine. And then on line 30, which, come on, is this param block, we have, this is the trickier one, where there are 2 parameters in the same parameter set name, so parameter set 1, where value from pipeline was true, they were other param 1 and other param 2. So we got the names of them there. And then notice that's where our output ends, because these 3 are in a different parameter set. And there's only one in this parameter set, other param 5, that had value from pipeline set as true. These other 2 were false. So this one wasn't a violation, and we did not get a false positive on it. And so, again, I mentioned this is not a perfect solution by any stretch of the imagination. Some ideas for improvement. What if the same parameter set name exists in multiple scopes? Am I going to capture this more than once, or am I going to have trouble with it? In this scenario, I had 3 distinct parameter set names of no parameter set name, 1, and 2. We would have to do a little bit more digging to make sure that I was capturing appropriately all of my use cases. Unit tests would be good, right? I should probably make some tests and make this thing actually able to be tested actively. I need a lot more use cases because there's a whole lot more ways you can screw this up. Like for instance, what are the parameter set names are in double quotes versus single quotes? You saw that right here, the single quotes are included. If they were double quotes, would they have been identified as different parameter sets? Again, 45-minute session, we didn't really have time to get too crazy with that. But that, ladies and gentlemen, is a crash course in building your own PSScriptAnalyzer rules. You have everything you need to know. If we look real quick, we identified how to identify the violations. to violate the violations. We learned how to identify those. We learned the syntax for doing the PSScriptAnalyzer rules. It's not perfectly polished, but now you have everything you need to make your own. And so I would love to hear from you if you make any of your own rules. If you want to talk or you need help, hit me up on Twitter. Otherwise, thank you guys very much for coming. It's been a distinct pleasure and a privilege to be here in front of you today. I hope you enjoyed the session and enjoy the rest of the conference.